Welcome to aminacademy.com. Let us do live stories of scientists. In that, we'll discuss about Niels Bohr. The Danish physicist Niels Bohr is generally regarded as one of the foremost physicists of the 20th century. He was the first to apply the quantum concept, which restricts the energy of system to certain discrete values, to the problem of atomic and molecular structure. For this work, he received the Nobel Prize for Physics in 1922. His manifold roles in the origin of development of quantum physics may be his most important contribution, but through his long career, his involvements were substantially broader, both inside and outside the world of physics. Let us discuss more about Niels Bohr. Niels Bohr was born and raised in Copenhagen. After his doctorate, he spent a number of years abroad, including the Manchester and Cambridge, before returning to Denmark to become head of Copenhagen University's Institute for Theoretical Physics, now Niels Bohr Institute. The institute became a legendary research environment and a center for the development of quantum physics. Bohr became one of Denmark's most famous and acclaimed people and a central figure in 20th century physics. Niels Bohr's atomic model. The Bohr's model is a model of the atom that depicts electrons orbiting a small positively charged nucleus. It was developed by Niels Bohr between 1911 and 1918. How it works? The model depicts electrons orbiting the nucleus in a circular path called shells. Each shell has a fixed distance from the nucleus and a fixed amount of energy. Electron can move between shells by absorbing or emitting energies. The energy levels of electrons are quantized, means they can only have certain values. Why it is important, this model? The Bohr model was the first successful model of the atom. It explained the absorption and emission of radiation. It was a big step towards the development of quantum mechanics. It has also some limitations also. It does not work well for complex atoms. It does not explain why some spectral lines are more intense than others. It does not explain the shape of molecules. The Bohr's first contribution to the emerging new idea of quantum physics started in 1912. Only the year before, Ernest Rutherford and his collaborators at the University of Manchester had established experimentally that the atom consists of heavy positively charged nucleus with substantially lighter negatively charged electrons circling around it at considerable distances. According to classical physics, such a system would be unstable. The Bohr felt compelled to postulate in a substantive trilogy of articles published in the Philosophical Magazine in 1913 that electrons could only occupy particular orbits determined by the quantum of action, and that electromagnetic radiation from one atom occurred only when an electron jumped to a lower energy orbit. Although radical and unacceptable to most physicists at that time, the Bohr atomic model was able to account for an ever increasing number of experimental data, famously starting with the special line series emitted by hydrogen. During the academic year 1926 to 27, Werner Heisenberg served as Bohr's assistant in Copenhagen, where he formulated the fundamental uncertainty principle as a consequence of quantum mechanics. Bohr, Heisenberg, and a few others then went on to develop what came to be known as the Copenhagen interpretation of quantum mechanics, which still provides a conceptual basis for the theory. A central element of the Copenhagen interpretation is Bohr's complementary principle presented for the first time in 1927 conference in Como, Italy. Nuclear physics. In the early 1930s, Bohr, together with Havesi and the Danish physiologist August Krogh, applied for support from the Rockefeller Foundation to build a cyclotron, a kind of particle accelerator recently invented by Ernest O. Lawrence in the United States as a means to pursue biological studies. Although Bohr intended to use the cyclotron primarily for investigations in nuclear physics, it could also produce isotopes of elements involved in organic process, making it possible in particular to extend the radioactive indicator method invented the promoted by Havesi to biological purposes. Splitting the atom. After the German physicists Otto Hahn and Fritz Strassmann in late 1938 had made the unexpected and unexplained experimental discovery that a uranium atom can be split in two approximately equal halves when bombarded with neutrons. A theoretical explanation based on Bohr's recently proposed theory of the compound nucleus was suggested by two Austrian physicists close to Bohr, Lise Meitner and her nephew Otto Robert Friest. The explanation was soon confirmed in experiments by Meitner and Friest at the institute. So far, we discussed about little about Niels Bohr and his atomic model. We have done. Please subscribe our YouTube channel.